I will copy from the last week example, which we have discussed. I will copy the class, the student class, and that's it. So, and I can also copy the IO stream and string.h, because I will need 5 to 10 minutes to write this class again. I will just remind you what's here. So last week we covered classes again. So we started talking about classes, and again we have seen the way encapsulation works. Remember, encapsulation means protect your data, so the attributes are private. And after that, we provide the public interface. So by interface, I will always refer to a collection of public methods. So here I have the constructor, and today we will cover always a lot of different ways to define constructors and the relation between them. So this will be about constructors today. We have the get methods, and generally they will provide read access. Get has scholarship and so on. Now, remember, when you have a pointer inside your class, it doesn't matter it's a static array or a dynamic array. Don't return the address itself. Don't return the address. So here, this is not okay. I will not keep this in my today example. For array of chars, you have two possibilities. You can either return a string. So in that way, you return a string, and the client, which will call get name value, will get this string directly, and they can print it, they can use it, whatever. Or if you still want to return a pointer to an array with the same type, in this case, a char array, a pointer to a char array, then do a copy. Okay, so here I have a copy, get name values as pointer, and here I'm creating a copy of the char array. So in the end, I can keep both. Okay, no one says that for each attribute you should have only one get. No, I can have multiple get methods. And again, get, it's a formal, it's an informal convention, because if you share this code with your colleague in China, they will know what's the meaning of these get methods. Okay, so get is not a keyword, but it's used, and informally it will actually say that you want to share some data which is protected, it's private, you want to share it with the outside world, with other classes and other methods. Okay, so this was the set of public methods to provide read access. Okay, and now for writing access, remember, this is very important. We will always validate the input, because otherwise, if you just send me a set age and you just do this, I can set any values in your attributes. And remember, you are responsible for the quality of the data in that object, in this case, the student object. So we should always validate. So here I have value this age. I validate that the age should be between 10 and 100. And in that case, I will allow the change. And otherwise, you have here, and some of you already mentioned that, we can print a message. We can choose not to do nothing. Don't do either of this. We are in C++, and we can actually throw exceptions. We generally will make the program crash. And some of your colleagues asked me yesterday, so what's the idea of this? So why do we throw exceptions? Okay, so we understand we validate, and if the value is not correct, we throw an exception. But how this can be used further? Because we know the application will crash. Okay, and I will open the discussion here again. And again, here for booleans, this is a particular type. Remember, don't ask for the obvious, because here I can send you either true or false. So sometimes this can be misleading. So for the boolean, because the boolean has only two valid values, true or false, in this way, I will not ask you for the value, but the method itself is actually saying how we actually change the has scholarship attribute. You see, when you will call gain scholarship, it's obviously you will have a scholarship. When you call loses scholarship, it's obviously the student will not have a scholarship anymore. So that's why don't ask here for something you should always expect to be false. Okay, so don't say Boolean value. And here you validate that this value should always be false because the student will lose the scholarship. Okay, so don't ask for the obvious. Okay, because that will lead to strange situations. They will pass you through. Okay, so lose the scholarship through. What it means? It means it's losing the scholarship, or it means that it's actually gaining the scholarship because you said here equals value. So for Booleans, try to manage them in this way, and your code will be much more easy to read and understand. Okay, now remember that you decide what you define here on the public space. Now you see I have removed that method, and now I have a compiler error because I don't have the set scholarship, but I will fix this line because I have these two other opportunities to choose from. So remember that you choose what's on the public space. You are in control always. So at some point, if you want to say, hey, I will not allow you to change the name, but I need this set name for other methods that I will use here. So you are here. This is your playground. Okay, the class, it's your playground, it's your sandbox. So here you can use anything from here. When we talk about encapsulation private public, we will always refer to the outside world, to the other kids with other sandboxes. Okay, so here you can say, hey, I need a set name method for me, but I will not allow you to change the student name. So in that case, I will define the set name method private. So in this case, I will be the only one that can use the set name method. And I will use it because I don't want to copy this 5 lines of source code every time I want to change the name of the student. Okay. So again, you are in full control. No one says that all set get methods or all the methods in your class should be public. You can choose. And you see here, I have a public area which starts here, which is covering all these methods up to this point. And after that, I say, hey, I want another private area. So you can use private, public, and later during the semester protected as many times as you need. Okay, so this label has an effect after this line until the end of the class, or until you open another section again. So for example, here I will open another public area. Okay, now in terms of readability, yeah, it's recommended to group the methods in a single private area and public area. So switching between public, private, again public, again private, at some point it will be quite difficult to see which methods are public, which are private. Okay, so generally it's recommended to have a single private area and a single public area and so on and so on. But again, I can choose the way I code. Okay, so let's fix that error. But before that, let's define main because I need to compile this source code. So now I have a compiler error here because I removed the generic set scholarship. So now I have two options, either gain scholarship or lose scholarship. And this constructor, and remember, the class constructor is a special method. This is the last part of the last week. It's a method. Again, it's not mandatory to be public, and I will explain you today when to make your constructors public and not, and which constructors should you make public. Okay, so it's a special function because you see it's quite special. It doesn't have a return type because by default all constructors will return a student. So when they decided to define the rule about constructor, they said, hey, they said this. So a constructor, it's a method which always return a student. So actually the formal definition should be this, student, student. So if you try to write a constructor which will return something else, that will not be okay. So in order to prevent this happening, to do mistakes like this, to write here void, they said, hey, don't write anything. Because again, don't ask for the obvious, okay? So if the constructor will always return a student, why do you put me to write that there as a programmer? So that's why all constructors in all programming languages, Java, C#, Python, whatever, TypeScript, they don't ask for the type, okay? You don't have a return type because it's implicit. It's default the same as your class. Okay, So this is strange because all the methods should return something, or they should have a return type like void. Now, another important characteristic of a constructor is that the name of the class is identical with the name of the class, and C++ is case sensitive. So student with SME here is not the same name. We know that because C is also case sensitive. So the name of the constructors are identical with the name of the class. Okay. And after that, it's a normal method like any other method. Remember, we have discussed about this last week. We introduced this, and remember, this is the pointer to the object which will call these methods, because all these methods, in order to be executed, they need an object. And here, this is the pointer to the object which we construct, which we build. So this is actually the student object, which will be created by this constructor. Now, let's fix this error. So now I have two set methods, but neither requires a Boolean because they are specialized. One will set always true, the scholarship to true, the other one to false. So here I need to do this if, or we can use the ternary operator or the conditional operator. For example, with the conditional operator, I will say this: has scholarship question mark. And remember, this is a Boolean, which means if this is true, do that, if else, do that. So if this is true, I can say this set gains scholarship. Otherwise, this loses. Yeah, it has an issue here because, yeah, let's try to copy. It doesn't see the, let's see, maybe I have a compiler error. Maybe I can't do that. Okay, now sometimes the IntelliSense is not helping. So this will be using the ternary operator. So this is like if has scholarship, if this value is true, then do this, gain scholarship, else this loses scholarship. Okay, so you see, that's why I prefer using this operator every time I have the chance, because otherwise I need to write like 6 lines of code to do the same stuff. Is this has scholarship equals has scholarship good enough? Yeah, so that's a very good question. So why we don't actually say this? So this is your colleague question. Why is not good enough to say this? This has scholarship, which is the attribute equals has scholarship. So it's a good solution. It will work, but generally, and maybe it will not be our examples cases. Okay, so we can live with that. Okay, you can write this without any issue. But generally, try to separate things, because you see, if you have a method which already sets that to true, or it sets this to false, just think in the future. Always try to code, but thinking for the future changes. Obviously, if you have some statistics, and I will introduce an example now, and thank you for the question, because it's an opportunity that I want to use. If we have some statistics regarding how many students they have scholarship and how many students they don't, then where do you want to increase that number or decrease that number? Regarding the number of students with scholarship, where do you want to increase it? So always think that checking the value at the source is better than checking the value afterwards. And this is like taxes. You know that in Romania and most of the Europe, the state will take the taxes at the source. So when you have a salary, you know, you get the net income, but the state will always get all those taxes on health, on social assurance, and so on. So you get the net value. Okay, the state will always get its part. Now, in other parts of the world, like states, you know, they get the whole value of the salary, and each individual is responsible for paying its own taxes later. So by getting the taxes at the beginning, the state is assured that everybody will pay the taxes. And sometimes this is a good approach. So in programming, if you want to count or if you want to analyze something, it's always to do that at the source. So where is the best place to increment the number of students or decrement it, the number of students with scholarships? Here, in the only method which will change that. So later, if we want to count how many students we have in the system with scholarship, this will be the perfect place, because if we know that all the source code will go to gain scholarship method in order to set the scholarship to true for that student, this is perfect. This we can increment that value. And you will always be sure that that value will be updated each time someone will call gain scholarship. And on lose this scholarship, we will increment the value downwards, right? So again, here you will know, you can update that value. So this will be the perspective or my argument saying, I will always prefer, instead of writing this, I will always prefer to call these methods, because later I can extend the logic of my solution by adding additional stuff here. You see, without these methods, you need to go through the entire source code, through all the source code, and try to see where you change the scholarship. And every time you see this, you need to do an if. If has scholarship is false, decrease that, or you see? So you will work much more later rather than implementing the functions and going through the functions. So always go on this approach. Define functions and use them to manage that thing. And always go through the function, because that will be your central point. You can extend the logic of your solution there. But again, this is also okay. So we can actually do this. Okay, so it will do the job. But if you have the set methods, I recommend you to go through those methods. Yeah.
I wanted to ask, is there a problem with the order? Because I can see that the parameters are in a different order of the
here.
Yeah.
No. So the order of the arguments here is something you decide. Okay. So for example, so let's, I will finish the answer to your colleague. So it's okay. It's okay also like this. Okay. So if you have validations, let's see, this is another argument. If you need validations, it's better to call the set method, because you do the validation in set method. Otherwise, you need to copy paste the same rules. Okay, so I can leave this as an option also. Regarding the other question, so can we have constructors with different combinations, or is the order here, like your colleague asked, is mandatory? Do you need to provide the order exactly like here? No, we can define constructors with any order. For example, I can define another constructor. So I will just copy paste, because in the end, it is the same stuff. So let's copy this constructor. Okay. And here I may say, hey, I will provide you another constructor with when the has scholarship is after name and now it's age. So this is another valid constructor. And by doing that, we actually open another topic related to object-oriented. And this is called overloading. So maybe some of you already heard about overloading. So what's overloading? Now, overloading means, and this is something from C, okay? It's not specific to C++. Overriding will be specific to C++. So overloading means that at any time, you can actually define multiple methods with the same name, and obviously something should be different. And you can deduce that rule from this next example. So here I'm in the global space. Let's say I want to write a function which adds two numbers, add numbers. Okay, so here I'll say int A, int B, just to understand what overloading means. So obviously this will do, okay, it's not rocket science, A plus B. Okay, now maybe I want to add three numbers. So can I define another function with three arguments, but with the same name? Let's see. Int A, int B, int C. So here, obviously, I would say A plus B plus C. Great.
It's not the same name. You forgot tennis, I think.
Ah, yeah, it's not. So it's not overloading. Thank you. Okay, so now I have the same method with the same name. And this one has 3 arguments. This has 2. And you see, for the compiler, it's no issue. So if I try to call it, so let's say int result equals add numbers, and I will say 10, 20, it will return obviously 30. And here I can say add numbers of 10, 20, 30. And you see it's working. So I don't have any compiler error. Everything is okay. Why? Because you realize that in order to identify a function, the compiler is actually using the function signature as the rule based on which the compiler will find the body of that function, which means the signature will always validate the call here and here. So if I look at these 2 functions, it's obvious they have the same name, which is great because I don't need to invent new names. You see, in the end, add numbers is perfect for 2 numbers, add numbers is perfect for 3 numbers, add numbers will be perfect for 5, 6, 7, whatever, because will always mean the same. And I don't need to know for doing same stuff, but with different numbers, with multiple numbers, I don't need to know multiple names, like add 2 numbers, add 3 numbers, add 4 numbers. No, I just need to know add numbers. So it's very convenient to reuse function names to do the same thing. That's very important. So if you check this signature against this signature, what's the difference? How the compiler can determine that this is the version with 2 and this is the version with 3. So what's the detail here which makes the difference between this one and this one? What's it? So what's the rule that the compiler is using to make the difference?
The parameters.
The parameters list, right?
Yeah.
So in this case here you have 2, and in the other you have 3 variables. Okay, so this is overloading. This is the concept of overloading, and it's from C. And this concept, it's available in all programming languages, all of them. TypeScript, JavaScript, Python, all of them. Okay, so all of them, they provide overloading.
So
it's
this
not...
is benefit, right? It's good.
Yeah, it's good. Why? Because remember, humans, we are very lousy of managing multiple details, complex stuff. So in order for humans to actually do something in a good way, we need to simplify. You need to break that complex stuff into smaller parts, which are much more easy manageable. Okay, so you see here, we are actually simplifying programming because based on overloading, I don't need to have multiple function names for functions which actually do the same stuff, adding numbers, but the difference will be in details. One function has 2 variables, one has 3. So overloading means we can actually define multiple functions with the same name. And the only thing that we should make different is the list of parameters. And the obvious detail is the number. So if I try to define another one with 2 integers and do a build or rebuild, you see, now I have an error and it's saying function add already has a body. And here it's saying you are not calling it. So it will give you a similar error. Okay, now, can I define a function add numbers with 2 variables, but with different types? Let's see. Float A, float B. So now let's say return A plus B. Obviously, when we add 2 float values, we expect to get a float type, right? Because otherwise you lose the precision. So let's see, build, rebuild. Okay, it has nothing to complain. Let's see, float real result from real values equals add numbers of 1.2 and 3.4. So let's see, build, rebuild. Okay, add numbers. And now you see I have another error. It's saying more than one instance of overloading function add numbers matches the argument list. Add numbers ambiguous call. So what's the version of which is ambiguous? You see at this point, when you have 1.2 and 3.4, this is actually float. The issue is that 10 and 20 can easily be converted to 10.0 and 20.0. And that's why now this is ambiguous, because the compiler cannot decide which version do you want to use. So in this case, if I want to say, hey, this is the add numbers for float, I need to do a cast here, float. And now you see the compiler is saying, now you want to use this version. So again, by overloading, you see, we can define multiple methods with the same name, and we can also preserve the number of parameters. But the rule here, the detail, which makes the difference, is the type. Okay, so you can actually define multiple methods with the same name, with the same number of parameters, but you need to make something different. So the number of parameters is the same. There is no difference here. So the other thing that you need to change is their type. So right now you have float here and float here. And this is overloading. Okay. And this is the principle which exists in all programming languages. Okay. Not just C, C++. In all of them. In Java, you'll do the same. Okay. So let's write here the detail. Overloading, what means defining multiple methods with the same name of the function, but with different arguments lists. So what's different about the arguments list? The number of arguments or their type, if they match, if the number of arguments is the same. When it is different, it's obvious which one is the version of the function. The type of the arguments from left to right. Okay, so the compiler is checking, hey, you are a float, you are an int. Okay, I can make a distinction between you and you. Okay, so this is overloading. And now, because we understand that we can actually do this, we can define multiple methods with the same name and different arguments list. And by different, I mean number or type. I think now, once we understand that this is something we can do, I think now this doesn't look strange anymore. Okay, to define another constructor with the same name. And remember here, all the constructors, they have the same name and with a different arguments list. So let's see, if I compare these two constructors, they both have 3 arguments, but their order, their type from left to right is different. This has a name, this has a name, which is a char asterisk. This has an integer age, this has a Boolean scholarship. Okay, so right now, I think it should be clear that you can define multiple constructors with different arguments list. For example, so I have these 2. Maybe now I will say, hey, let's wait for a minute, because by default, when you create a student, when you enroll, okay, you don't have a scholarship. There is a contest, whatever, okay? So it's not like you enroll and you have a scholarship instantly. So let's provide a constructor which will ask for the name, because name is mandatory, const char asterisk name, okay? And I will not ask for the whole scholarship, because by default, when you create a student, when you enroll a student, let's say it has no scholarship, okay? It's by default false. So I'll say here age, and you see this is another constructor. And in this case, I ask only for 2 arguments. So this is obvious different from the other 2 because you have only 2 arguments. So here I'll say this set age. You see the advantage of having the set methods, even if you have them private, you don't need to copy paste a lot of source code. Remember, without the set methods, you need to copy paste each time you implement a constructor this part, and your constructors will be very large in terms of lines of code. That's why I always start with setters and getters. Even if you don't define all the setters public, at least define them private because you want to use them here. Okay, so you see the advantage. The code has very few lines of code, which means it's easy to read, understand, change it, and so on. So in this case, for scholarship, I will say false equals false. Okay, and now I have this set name name. Okay, so again, this is another constructor. Maybe you will say, hey, can we have a constructor, a student with only the name? Yes, we can have that. But the question will be, what will be the default age? So let's copy this one here. Let's remove the age. So in this case, what will be the default age? So because you need to set the age, and remember by default, they are all 0xCCC. So if I write here 0, that will not be okay because the program will crash. Remember, we validated here. Okay, so if you call your set age with 0, it will crash. Let me show you. So let's test these constructors. And when I will test this one, the program will crash. So let's test the first constructor here. Okay, testing the constructors. Okay, so student. And now I will create Alice, let's say. And you see, again, this is the C++ way. You open the brackets here. This is like Alice is a function, but not Alice is an object. But yeah, this is the way they choose how to define this stuff. In C# and .NET, this doesn't work anymore. It's always with new. You will see that next semester. But in C++, again, the brackets are actually here after the object name. So let's test this constructor, name, age, and has scholarship. So here I will say, you see, again, I told you in the first weeks, always use the tools that you have at your disposal. Use IntelliSense. Right now, I have 3 or 4 constructors. So it will be quite difficult to remember the order of the arguments and so on. So when you open this, press Control space or try to activate the, yeah, but sometimes the IntelliSense doesn't work. So here, IntelliSense should activate. Let's say if it's activating now, Alice, yeah, it's activating after the first argument. Thank you for that. Sometimes it's too late. Okay, so at least I have this const char asterisk name, so is Alice. And you see these arrows, I can go through all the constructors. So I have const char asterisk name. I have the one with name and age. I have the one with name, Boolean, has scholarship and age. And I have the other one with name, age, and has scholarship. So always use the IntelliSense, okay? Because after, without that, you just need to scroll back, scroll down here, scroll back here, okay? So let's use the one with Boolean. So here, true. And the last one, age, let's say 21. Now let's build another student. This is John. John. So let's use the other constructor, John. Which means 21 and false. Okay. Now let's create a student with a constructor that has only name and age. So this is Bob. Okay. And here, let's say 20. Okay. And now let's try to call the constructor with only the name, and the application will crash. Let me show you that it will crash. So let's rebuild. Okay, so 160 failed. And if we run this, debug, start without debugging, again, I see no errors. So in order to see the data, let's write a function which will print the data. Okay, because I don't want to check it in the debugger. So let's go here on the public space, either here or here. So let's go here. So let's define a method, void print student data. So, or print info, let's say. We know that this method will receive by default this pointer. So here I can print the data like here. And generally, because we will print a lot of objects on the screen, we will be overwhelmed about the information that we will see. So generally, I have this approach. I will always, again, for didactic perspective, you don't do that in real production, just to help me see the difference where an object between objects in the console. So I just use this approach, and it will be much more easier to follow the output. Okay, so now I will say end line name, and here I can say either this get name value. Was that get name value? This is the name we use it, get name value. Get name value, yeah, because get name was the wrong version, and I removed that. Okay, get name value. Okay, or cout end line. Now, because here you are again inside the class, you can also write here this name is the same because we have access to that. So let's do that with age. Let me show you. You don't need to call the getters here. Okay, so here I'll say this age directly. Remember, we have access on our private space, and cout end line. Let's say has scholarship. Now for has scholarship, remember that here we do the is returning true or false, but remember we see that as 1 and 0. We did that several weeks ago. So for has scholarship, I will again use the ternary operator because I want to return true or false. Remember, it's returning 0 or 1 by default. So the question is, this has scholarship. This is the question. If this student has a scholarship, if yes, I want to get true. Otherwise, I want to get false. Okay. So now instead of printing all this data again and again, I will just call print info. Okay. So build, rebuild. So let's check our students. Let's see our students. Okay. So I will go here and let's print them. So I will say Alice dot print info. Remember, I can't call a method without an object. So I can't say just print info. And this is actually this inside that function. And after that, I will say John, and this will be the address of John, print info. And now I will say Bob, print info. Okay, so if I will run this program, build, rebuild, debug start without debugging, here they are. Again, like I see, yeah, sorry, let me show you. Like I said, you see those dotted lines are helpful because now I can see clearly where is Alice, John, and Bob. So now I can see all the data for my students. Again, exit code 0, which means it should be okay. So if I go back here and now try to call the constructor, which let's say, because it will crash, let's make this student Vader. And here I'll say Vader. So right now, if I will run this program, build, rebuild, okay, and debug start without debugging. Okay, 1 second, I just need to run it again. This is what I get. Okay, let me share the entire screen. Okay, I got the debug error and so on and so on. You see the program is terminated instantly because we have that throw exception. And here I will say abort and exit code 3. Okay, so in this case, if I implement that constructor in that way, this will always crash. Okay, if we call the set method. So watch out what you do here. So in this case, for this constructor, I will not call this set age 0 because it will instantly crash. So here I need to make a decision. So if we want to leave the value to 0, so if you want to say, hey, if you create a student and you don't have the age of that student, you can set it to 0. So in that case, we use a shortcut. We are in our own playground, so we do what we want to do. So here I will say age 0. So I will pass, I will just go around the set age method. So in this case, the program will not crash here, and I will say build, rebuild. And now if I run it, debug start without debugging, it's everything, it's okay. And if we print Vader, we will see that Vader has age 0. So let's do that. So Vader print info. Okay, so build, rebuild, and debug start without debugging. Okay, and now you will see that Vader has age 0. Okay, or let's stop and think for a moment. So in reality, so what's the alternative? The alternative will be not to provide this constructor. And now we start to open a philosophical debate. So in reality, when you enroll a student into a faculty, which use case do you think should be always the only use case? To register students with all their personal data, or to register students with the name and maybe tomorrow you will add the age? Which one do you think should be the only way to do it? And
All the data.
All the data, right? Because who knows what will happen tomorrow? Maybe the secretary will get sick, so he or she will forget to update the age. You forget to bring up the documents, and so on and so on. It will be a mess. It will be like you will graduate and they will say to you, so you have graduated here, you are our student. We don't remember you. You are not in the database. There is only one name, like, I don't know, John. So who are you? Yeah, I'm John. We don't know. We don't have your documents. Why didn't you brought the documents? So remember, software, it's a digital representation of real life. Okay, so we are not living in a matrix. Software is not an extension of reality. No, software should map on reality, because software should help us solve real issues from reality. So when you design classes, don't give the chance to you in the future or your colleagues to actually create inconsistent data, because that will throw back to you a lot of bugs and a lot of issues. So you see here, this is a very important moment. Now we decide which is the minimum information that we should require for a student. And here, in order to find the answer to this, you need to go to the secretary, you need to go to check the enrollment methodology and see which is the amount of data that you need. And the software should follow that. Because if you do it differently, this is when they will hack the system. Okay, this is how others will insert by mistake or willingly inconsistent data, which in the end will generate a lot of issues. So based on this idea, and remember, coding is not just coding. Okay, it's like you just close your eyes and you code and that's it. No, you need to think, and you need to think at the consequences and how this solution is mapping to the real life. So based on this discussion, I think that this constructor should not exist here, because I think for all of us, it's obvious that if you want to create a student, you should provide us at least the name and the age. Okay, so always think, when you design classes, think on this perspective. And this is actually talking about designing classes, which is above just coding OOP. This is designing classes, and we will have different topics about that. So from this perspective, I will choose not to implement this constructor, but I think I showed you and you understood that we can have this constructor if we would like that with only one argument. And I choose, so it's my option not to implement it, because if you don't define it, it will not exist. So let's say we choose not to implement it, but we could do that. We choose not to implement it because we consider that name and age are mandatory. And you see, this rule, it's valuable, has a value only for this example. Okay, so this doesn't mean that all student classes should have name or age. Maybe when we design a real system, we realize that name, age, and the numeric personal numbers should be mandatory. or maybe just the numeric personal number, age, and whatever else, and birthday, even if that is part of the numeric personal number in Romania. Okay, so here, this is something you will learn during this semester, next semester, third year, at your first job, and for many years of coding, designing classes. There are courses on that, but you need to feel it. You need to hit walls, okay? And when it will hurt, you will realize that you had a bad design several months ago when you defined those classes. And until you reach that point, it's very difficult to learn. So this should be a personal experience for each of you. But this is actually designing classes. You need to think what tools you should provide. And you see, again, it's about control. Because now, if I don't provide this constructor, they can't use it. Because you see, no instance of constructor student matches the argument list, const char, which means, hey, the owner of this class never provided the constructor with only one char array. So they can't do this. So at this point, if they want to define Vader, what are their options? Their options are this, either like this, or like this, or like this. Now, between these two constructors, let's ask a question. Do they actually bring any added value? So having a constructor with name, Boolean, age, int, and another one with name, age, and Boolean, do you think we have we add value, or quite we create some confusion? What do you think? What's your subjective opinion? Should we have two constructors with the same values but with different orders?
I don't think we should.
Why? Because it will create confusion, right? So
Yeah.
someone will ask us now, is any difference between this one and this one? And you will say, no, there's no difference. So they do the same stuff in the same way. So why have you done that? I don't know, just for fun. So another conclusion, and again, this is designing classes. If you provide a constructor which will ask for some data, don't provide another one with the same data, but with a different order, okay? So we see we can do that because overloading allows us to do that. But in terms of design, in terms of making this very clear to others, try to avoid this. So at this point, we need to choose between these two, okay? So generally, let's keep one. And if you ask me, and I think this is the reason why I initially define it like this, for me, it's more naturally, despite the fact that here I have the head scholarship after name, for me, it's like name, age are more important than scholarship. So for me, it's more naturally to say name, age, and scholarship, okay? So that's why I think in the first place, I designed that. So again, let's comment this one from here, or let's, yeah, because it will remain. So just for this course. Okay, so we do this only for this course. It, let's say, it might create a confusion with the previous one because they ask for the same data. Okay, so this is another rule. They ask for the same data. Okay, so generally we don't do this. So generally we will try to provide a constructor maybe which will ask all the values. And in that way, if someone wants to create a student with all the data, we'll have the chance to do that. Okay, maybe we will provide partial constructors, which means I will have a constructor which asks only for some data, which I consider to be important, like name and age, like we have it here. So we will have different combinations, but not because we have different orders of arguments, but because we ask for different data. Okay, so again, you see designing versus implementation. Based on implementation, you can do whatever you like, but based on designing and just thinking how that will look like, some things should not be implemented. Okay, now, in order to finish the discussion with the constructors, because now you can see you can have any number of constructors, remember that last week, if you go through the recordings, when we defined the first object, I did it like this. Let me show you. So I will, yeah, just write it here. I did it like this: student, Vader, and that's it. And if you remember, it worked. So I didn't got an error saying, let me show you the error, no default constructor exists. Okay, so you see, is not saying there is no constructor matching this argument list, which means no arguments list. It's saying no default constructor. Okay, so this is special. This constructor is special. Now, I have here two questions. Where is it? Because we have it, now it's gone. Why it's gone? And what's the idea of the default constructor? What's the default constructor? Now, let me show you what's the default constructor. So here, I will define another class faculty. Okay, string name, string address. Okay, so you see, this is a class. Remember, implicitly, everything is private here. So now let's try to create an object of this class. So I will go here and I will try to do the same stuff. Faculty, XIE, cybernetics, and so on. Okay, I don't have any error here. So I have a default constructor for faculty, but I don't have a default constructor for student, but I had one, if you remember the last week course. Okay, let me show you something else. And you see, you actually deduce the rules of object-oriented. If you just play with it, you will actually learn it. Okay, you don't need to memorize. That's why I'm not going through the slides. Okay, you can read the slides, but don't memorize them. Try to understand them and learn by doing. It's much more powerful than just listening to me and reading some slides. So let me do something here, because we have this context. Where is the default constructor? What's the default constructor? So here I will say faculty, string name, string address. Okay, and now I will say this name equals name, this address equals address. Okay, so you see I implemented the constructor which asks for the two values. Let's go to main. I have the same error now. No default constructor exists for class faculty. So what will be the conclusion? The conclusion sounds like this. If you define a class, you get a bonus. So if I delete this constructor, the error is gone and I can build the faculty. So when you define a class, by just defining the attributes and that's it, or by just not defining anything, but just the class itself, you will always get this bonus for free. So it's free. It's like you define the class and you get the constructor as a bonus. And the compiler will always give you the default constructor. You understand why it's called the default constructor? Because you get it by default. Okay, you get it for free. And in programming, for free means by default. So every time you define a class, you get the default constructor for free. You get it. You see, this is the proof. So what that constructor will do, we'll create a faculty with a name and an address. Now, what will be the values there? The same values we get for any variables like 0xCCC, null, whatever. But you get that. Why? Because they said, hey, when someone defines a faculty, let's allow that person to be able to test instantly the class by creating objects of that class. So you see, by default, you can do that. So that's why they provide you the default constructor. So the default constructor is something you get it for free by default when you define the class. Now, why when we define a constructor, we don't have it anymore? So now you have it, now you don't. And you see that the thing that we did was to define our own constructor. And now the default constructor is missing from here and from here. Why is that? Because default constructors are very, very dangerous. They are quite dangerous, and you will understand why. So let's ask the next question. can we see the default constructor? So does it have a form? Can we actually see it? Yes, we can see it because we can actually write it. So when you define a class, you get by default the default constructor. But if you want to implement the default constructor, you can do it. So how the default constructor looks like? Again, it's another constructor, which means the name of the function is the same as with the class one. And why do you think it's called default? Because it will never ask for values. You see, when we have defined CA, no one said, hey, what's the name of the faculty? What's the address? So the default constructor is this one. This is what you get for free. And I think you realize that this is something that the compiler can easily generate for us. You see, this is the default constructor. Okay, it's a constructor with no values, and that's why it's called the default one. So right now, you see, I have defined it, and this is still okay. Let's define it also for student. So if I go here and I define it after the other ones, so let's say this is the default constructor. Okay, so here I'll say student. Okay, now I have the default constructor, which means now Vader can be built and also CA can be built. Okay, so let's resume the rules. If you don't define a constructor, you get one by default, which is called the default constructor. If you implement at least one constructor with arguments, you don't get the default one anymore. That's why this doesn't exist. But if you still need the default constructor, you need to write it, and this is how it looks like. It's a function without arguments, and this is the default constructor. So right now, Vader and CA, we can build them without data. Now, let's try to see what Vader data is using that default constructor. Print info. So build, rebuild. Okay. Debug, start without debugging. Here it is. I told you that sometimes we will see this. What's this? This is 0xccccc. And you see here I should see some data, and after that in memory I find again Bob. So I see Vader default 0xcc because he's not initialized that array, and after that it finds in memory Bob and stops. Fortunately, Bob has a backslash 0 here, and that's why it's stopping. Age is 0xccc, the minus 858 millions and so on. And by default, remember in C++, if you set a Boolean to a value different than 0, it's always is true. 0, it's false. So that's why it has a scholarship. So you see how Vader is hacking the system. If Vader is able to create a student with the default constructor, it will have a default scholarship because 0xccc is not 0. It's a value. It's this value here. So by default, scholarship will be true. Okay. So that's why don't let your data uninitialized, because for Booleans in C++, it's actually true. Okay. So you see, this is Vader. And now you may say, yeah, but it's useless because we don't have a name. We are lucky that the program didn't crash. It has by default a scholarship, which is not okay. Age was minus value and so on. So default constructors are dangerous. And this is one reason. Now, some of you will say, so let's try to, even if you wrote this function, let's at least do something. So if you implement the default constructor, yeah, don't leave it like this. Okay, at least do something to change that print info output. So let's see, this set name John Doe, because I don't know the name John Doe. Okay, John Doe. Okay, what else? This age equals 0, whatever. This has scholarship equals false. Okay, so you see, at least do that. Why? Because now if I do a build rebuild, okay, and debug start without debugging, let's try one more time. Debug start debugging without debugging, and if I share the screen, at least now we see something. John Doe, age 0, has scholarship false. Okay, so in this case, if you still want to implement the default constructor, at least set some default values which makes sense or a kind of sense, okay? Like John Doe 0 has scholarship. Now, if we go back to the reality versus software issue, and if I ask you, hey, how do you feel that a secretary or an operator can actually create a lot of John Doe students? Remember, we had this discussion with this one here, which was not asking for the age, for the age. At least it was asking for the name. And you see, we commented it and we said, no, 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 no. You should provide the name and at least the age. So you see, this one was not okay from that perspective, from the reality perspective. Now, what do you feel about this one? This one, it's even worse than the previous one. So that's why I'm saying always try to avoid the default constructors. And this is the way we will code through this semester. So you can blame me, okay? If, I don't know, C++ is becoming too difficult because of that. But yeah, this is just a drop in the ocean. So this is the way we will code, because based on my experience, avoiding the default constructor will do much more good than bad, okay? Bad things will happen if you provide a default constructor, especially in terms of the quality of data that you will have in the database, in the backend. You will have students with default values, and those are not students. You need real students, Alice, age, birthday, address, and so on and so on. So if you need the default constructor to create some temporary objects, okay, that you need to use for, I don't know, complex operations like searching, like filtering, like whatever you may need in the future, at least keep the default constructor for yourself, okay? So if you talk with your colleagues from other cities, okay, and you, I don't know, you share source code, you discuss on source code, which will be great. So if you do that, please continue, don't stop. And they will ask you, hey, why you don't have the default constructor, or why you have it private. And remember, if you want to define something only for you to be used here inside the class, make it private, okay? And in this way, you can use it, others cannot use it. So in that way, I will define the default constructor private, and this will be the only way to define it through the rest of the semester, okay? And all the other stuff, let's make it again public. Because, so if they will ask you this, try to explain them that in reality, software should collect data which you normally collect with a paper-based form, with data which you collect based on a methodology. Software should not leave other ways okay, for data, like inconsistent data, okay? So that's why if you need the default constructor, if I will need the default constructor, I will always define it private, okay? You can define it public, but you should understand the risks, okay? But in all my examples, I will always make it private, and these are my arguments. And if you follow this design rule for Java and other C#, other object-oriented languages, you will be okay, okay? So try to allow others to go for the default constructor, because default constructors generally do nothing. They just create the object and set some defaults. So that's why I will not insist on it. But this is the default constructor. At least you get it for free when you define a class. But after you define at least one constructor, it's gone. Why is gone? Because of the same arguments that I just presented to you several minutes ago. Default constructors are dangerous. They will let inconsistent data reach the database, so, or other parts of your software. So that's why when you define a constructor in your class, like here, the compiler will not give you the default one, because in this way, they understand the control that you need. Otherwise, it will be an exception to the control rule. It's like you can define all the constructors that you like. We will always offer the others the default one. So where is the control here? So this is another rule in object-oriented. You get the default constructor by default, but when you define the first constructor, they will not give that to you for free. Because in this way, they understand that if you want to provide the default constructor with this one here, it's your job to do it, and it's your decision to make. Okay, so that's why this goes away when you define another constructor. Okay, it's not a magic trick. It's because they want to give you the tools to have full control over the class. Remember the rules, you define the rules based on which others will use the class. And you see now, if I define the default constructor private, okay, so at this point, I will use it only for myself. So this one is private. If I go back in main, if they will try to use it, is inaccessible. Or if you comment it, it will say there is no default constructor. So choose wisely if you want to provide the default constructor. Okay, so choose wisely this one. So at this point, they can't. And this is because I want for this to happen. So it's my option. Okay, so I will write here a comment. So default constructor made it private because allows students with inconsistent data, like John Doe. Yeah, but this is a unknown name, right? 80 was this, and so on and so on. Okay, so this is the story about constructors. You can define multiple constructors. You can define based on overloading, you can define multiple constructors. You can receive the default one if your class doesn't have any constructor, but after that, you don't get this one. So if you need it, you need to write it down. Okay, and this is the default constructor. If you define it, my recommendation, and this is the way I will code, will be to make it private. Okay, because maybe I will need it, but for others, it's dangerous. Okay, so this is the story about constructors. So what will be the, let's say, like a general rule? When you define a class, provide several constructors. So in this way, the developers and you will be flexible. So you see, here we are very flexible. We can create students with all the data, or we can create students with at least the name and age. Okay, so this means being flexible, because sometimes you want to create students with the mandatory stuff, and maybe later they can add the scholarship. So they can add the scholarship for Alice. Yes, they can, because we have the set methods. So if Alice will take high grades, at some point it will get a scholarship. So it will gain a scholarship, gain scholarship. So you see, this is the power of the public interface. Now later you can set the scholarship for Alice, or maybe Alice next year will lose the scholarship, and so on and so on. So Bob the same. You see, Bob doesn't have a default scholarship, but again, Bob can gain a scholarship later. So you can still change that other data which you don't ask through the constructor, but at least define a set of 2-3 variables which should be mandatory, or at least one, 2, or 3. Okay, which should be mandatory. Okay, so this is the story about constructors. If you have any questions about them. And overloading, but overloading is something we will use. Okay, now let's continue. And you have seen here, generally when we define constructors which ask for partial data. Okay, for example, let's say that we add to the student, we add here this array, dynamic array of grades. Okay, and here I will say in number of grades. So you see, no students, any student which is enrolled at October 1st will have no grades, because there is an entire semester till the first exam session. So There are no grades when you create students in the system, right? They will come after that. So here, if I have this data, which doesn't make any sense to ask here in the constructors, because it makes no sense to ask for the grades at October 1st, because you don't have any grades, then I need to go through all my constructors here and actually set these values to some defaults that I can check later. For example, if I go to print info, where is it? Here, now print info should also print the grades. So generally here I will say, if this number of grades greater than 0, then we will print the grades. Cout end line grades. So we check if the student has some grades. For int I at 0, I less than this number of grades, I plus plus. Okay, cout and without an end line, this grades at index I. Okay, and the space. So you see right now we can actually print the grades if the student has some grades. Now we have all those constructors. Okay, all this one. Let's see what will happen if we run this project. Build, rebuild. 1 succeeded, 0 failed. Debug start without debugging. And this will happen. We don't see the grades. Okay, now let's make the program crash, and you'll understand why I will do in the next minutes. So let's change the rule to different than 0. You may say it's the same, right? Because number of grades can be either 0 or greater than 0, right? These are the normal values. So I just replace greater with different. So build, rebuild. Debug start without debugging. Okay, and it's still not showing us the grades, which is great. So yeah, what I want to prove, I just wanted for this program to crash. Let's set here a breaking point. I just want to check number of grades. So build, rebuild, start debug, start debugging. So it will go into the first print info. Let me check. Okay, so by default, yeah, but this will be for the first time it will happen, whatever. So you see now by default, I got number of grades 0. But wait a minute, we were used to see 0xCCC, and we have seen that last week, that by default we will get 0xCCC for attributes, and we have seen that for name and so on. But for number of grades, this time I get a 0, which is great. Now, let's not trust that this will always happen. Okay, so my point was that here I expected to see a 0xCCC and this will crash because there are no grades for the student. My point was, how can we make the initialization of attributes in a more efficient way rather than going through all these constructors and say, this number of grades equals 0. This grades equals null pointer. So you see, now I should go and copy these 2 lines and copy them here, actually in all the constructors, right? Because by default, this should be the default values. So how can I do this more efficient? Because copy pasting doesn't mean efficient. If you see yourself doing that, stop for a moment and try to find the smarter solution. Define a function. Try to find another way. Don't copy paste code. Okay, so how can I do that in a more efficient way? You see here, we are defining the variables. So can we actually set some real defaults? So in the end, it will not matter if we are compiling this on a Linux or a Microsoft Visual Studio compiler. Can we choose our own defaults? Because we don't want to expect to get 0xCCC and so on. And the answer is yes. So when you define a class and you define the attributes, choose your own defaults, and those defaults will replace the all the other default values that you will get from that specific compiler. So what will be the name for, remember, this is a static name, which means I can initialize it here. We did that. So let's say John Doe. Okay, I don't want to have an empty, or if you don't like John Doe, because maybe John Doe has a meaning in the US or Anglo-Saxon, let's say, environment, maybe you don't you want to provide empty string, which means no name, or maybe you want to provide the dash or whatever. So remember, static arrays can be initialized like this. Okay, has scholarship. Again, I want to be by default false. Age, I want to be by default 0. Grades, this is a pointer. I want to be by default not 0xCCC, but I want to have it null pointer. And number of grades, I want to be that by default. So you see, by doing this, now in every time you implement a constructor which asks for some data, you will focus only on that data. You don't need to worry about the others. So take this very important rule. When you define the class attributes, choose the default values for them. Okay, so you can choose your own defaults and do that. Okay, defaults, do it. Again, it will prevent very strange cases which will happen a lot of times. Okay, now let's introduce something something else. We have 10 minutes left out of the course, so yeah, let's talk about something that I missed to tell you, and I'm sorry about this. So I need to kind of go back to the discussion with pointers. So just not to mess up with your head. So this is about creating objects and initializing their data. You have seen all different ways of constructors. And again, you have seen that you have the power to choose the default values. Again, you have the power to decide which constructors do you want to provide to others. And from this spectrum, always choose if you want to provide the default one or not. And I recommend you not to provide the default one. At least keep it for yourself, keep it private. Now, what I want to show you, and this is important to C++, and this was part of the discussion with pointers when we talked about pointers. And I realized that last week when I sent your colleagues the first assignment, maybe some of you which are doing the seminar with Bogdan, you already covered that, but I want to be sure that everybody knows about this. So this is like a distinct part from another movie, like the course 2 weeks ago, is the reference in C++. Okay, and I think this is important because in the beginning you said that pointers are still an issue. So we have seen that pointers are helping us to change variables from other stacks. Let me give you an example. So I will take a very basic example just to present reference. Let's suppose here we have a counter. Okay, so this is the counter equals 0. So if I want to increment the counter, okay, I can easily do this. Increment, and I will say counter plus equals 1, or counter plus plus. So now if I display the counter, okay, the counter value is, we will see counter. Okay, so if I run this build rebuild, and we will see that now the counter is 1, right? So I incremented once, so the counter value is 1. Okay, now how do I do this with the function? So let's define a function which will increment the counter. So I'll say here void increment counter int counter or value. Okay, current value, whatever. So if I try to do it like here, I will do what? Value plus equals 1. And that's it. So in my mind, I will say, hey, this will increment the counter. Great. So if I try to increment the counter here again, I will say increment counter of counter. Okay, and after that, I want to print it. So I think at this point, it should be no surprise to anyone here in this Zoom session that the counter is still 1. Okay, so build, rebuild, debug, start without debugging. Again, I need to run it again. Debug, start without debugging. And here it is. You see, the counter value is still 1. Why is that? Again, a very short recap. Remember that we have the counter variable on the main stack. So this is the main stack. Okay, this is it, main stack, main. And on the main stack, you have the counter variable, which at this point has the value 1. And obviously, if we change the counter here on main, it will change this value. But if you call another function like increment counter, you'll have another stack. So this is increment counter. Okay. And here, the increment counter will have its own variable, which is called value. Let's draw it. This is value. And when you call increment counter, you actually get, remember I told you to imagine an equals. You get the value of counter, which means here, you get the value from here. So you get this value, but only the value. So here now you get 1. Now, the function will do what? We'll say value plus equal 1, which means this value now is 2. But you see this value, not the official counter, 2. So when we go back to main, this function stack is gone. This 2 is lost. And in the end, if you ask the main counter, this variable here, what is its value, it will say it's still 1. So when you pass variables by value, when you pass the value of the variable, if you change that value inside the function, you change the copy, because here you have a copy of the official variable. So here I told you that if you want to make the increment counter to be able to change this value from here, this official 1, you need to pass not the value, but its address. So let's say this address here is pound A. Okay. So how do we do that? How do we write the increment counter? So increment counter with pointer. And remember, when you define a pointer, you just start with the name. Pointer to counter, whatever, just name it. Add the asterisk, because this is what it makes the difference. This is actually the pointer, the asterisk here. And now ask the question, at this address, what's there? What's the type of the value there for which you want its address? It's an integer. So here you write int. And this could be another pointer, or it could be a student. So don't be afraid. Just ask the question, what's there? And if this was another pointer, you just write another asterisk. Okay, now it's just an integer. So right now, I can do this. The value at this address, because we did this in the first week. If you just increment the counter, if you do this, you see, you don't get any compiler error. Why? Because this is pointers arithmetic. When you say pointer to counter plus equals 1, this means move to the next integer in memory. Remember, pointers arithmetic. So obviously we don't want to do that. We want to change this value from here. So if you have this address pound A, how do you say the value at address pound A? Again, with asterisk. So pointer to counter now means pound A. Asterisk with pointer to counter means this one. Okay, the value at that address. So now I'm changing actually the value at that address. So if I will draw now the stack for the increment with pointer, inc with pointer, okay. On this stack now, I don't have the value of that counter. I have its address. So this will be a pointer 4 bytes. And now here I have its address. Okay, you will receive its address, A. Okay, so now we say this pointer points here. And that's why asterisk pointer to counter means asterisk to this address, which means this one. So now we actually change this to 2. Okay, so it's if I test this one here, and let's say increment counter with pointer. Now, if I say just counter, the compiler will say, no, 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 no. You said you want the address of an integer, not the value of an integer. So it's remembering us that we need to pass the address of the counter. So pound A. And now if I run the program, okay, and build, rebuild, and run this again, debug start without debugging. Now, let me share the screen. Where is the Zoom toolbar? New share. Now you will see the counter is 2. In the end, it's 2. Okay, because the function with the pointer has been able to change it. Okay, so this was the discussion we had with pointers and why pointers are valuable, because actually we get those addresses and so on. Now, when they design C++, if you just cross-check these two functions, you realize that the logic is the same. You just increment that variable, but this works, this doesn't work. Why? Because this receives the value, this receives the address, and by using the address works. Okay, and if you just cross-check them, you realize that in order to make this version work, you just need to actually add an asterisk for the input variable you want to change. So if I will copy this again, I know the algorithm. If I add this asterisk here, and now every time I see value, I will add an asterisk, now it will work because this version is actually this one. So a rule is like, if you want to receive a variable to your function, just write the function without thinking at pointers. Just write it like this. Focus on the algorithm. Be sure you do the right thing here. And now ask the question, hey, do I want to change the value which I receive here inside from this function, so the change will be visible also outside? And if the answer is yes, then you need to switch to pointers. Okay, you just add the extra asterisk. If not, leave it like this. Okay, you don't want to change the external value. So this is actually what happens. So in C++, they said, hey, yeah, that's true. Let's make the compiler do this for the developers. So they introduced this new type, which is called, it's not a new type. It's yeah, it's a new type, but it's also something we have seen. Increment counter with references. So they said, hey, just take the function that you wrote before without pointers. Okay, just take it. And now just ask the compiler to add the asterisks to those variables that you want to change. So always check the input arguments list. So which is the variable that I want to change? This one. So just mark it with a reference. And this is the C++ reference. This is almost identical to this one, but in reality, this version is this one. When you hit build, when I hit build, when I do this, this actually transforms to asterisks, and we don't see that, but we get this version. We get actually this version. Okay. So at this course and seminar, you can use either the classic pointer from C or the C++ reference, okay, at any time. So now if I want to use the increment counter with reference, I will use it as here. So you don't see the extra asterisk. Increment with references counter. Okay, and if I print it again, I will see the new value. Okay, build, rebuild. And this will be the last screen. Let's see, start without debugging. And here it is. Okay, now it's 3. Okay, so yeah, sorry about that. This should be part of the discussion with pointers, but I think we finished. And after that, the next week we started with a different story. Okay, so we can use both reference or pointers. I will use both. So during my examples, I will use both examples, both approaches, just to help you keep in touch with them. Okay, so this is all from my part. If you have any questions,